When we're given an example like this to find the specified zeros, we're actually going to have a polynomial of the degree 4, and it actually provides us the zeros for these. So if we want to look at the factors for those, right, just as we're kind of going backwards. So now it'd be like everything we did last week to find the factors. We're now going to go in reverse to find what polynomial it would be. If we had to give these as factors, this would be x plus 3. We're always doing the opposite. This next one would be x plus 0. Then we're going to get x minus 1. And this one would be x minus 5. These would all be the factors in which would make it zeros for this polynomial. Now, one thing that we're going to look up here is, I saw a good question like on the test on this, is what would be the polynomial that would represent these zeros? And it's very, very simple to do. Now, it might look complicated, but it's not too bad. And what we're going to basically do here is we're going to FOIL these out. We're going to FOIL out the whole thing. And what I would do is I'd do it by parts. So if we FOILed the first two together, and then FOIL the second two together, we'd be able to determine what those two are. Then we're going to FOIL that one even bigger. So it's easier to just to break it up. Our first terms here would be our first. So this would be x squared. Outer, x times 0 is just 0. Plus 3x. And then our last, which is plus 0. That's our first term. If we were to FOIL the second portion to this, we do the first, outer, inner, and last. This would be the second one in which you would get x squared minus 6x plus 5. And then we just bring down this other one. Now that we have two terms like this, all we're going to do is we're going to expand it one step further, meaning we're going to FOIL this out one step further to find our solution. I'm going to multiply all my first terms here by each term underneath. So this will give me x to the 4th minus 6x cubed plus 5x squared. Then we would do our last one here, our 3x by every term as well. And that would be our remainder. So we get plus 3x squared, or 3x cubed, sorry, minus 18x squared plus 15x. Now, what do we got to do with this real quick? How do we do this? Combine like terms. And it's just simplifying out. So this problem is something that would be really cool to give you guys on the test, just because it requires that you guys know what the zeros are, put them back in factor form, and factor everything back out, or expand it as they call it. In this case, what we get here, we got x to the 4th is our first term. CLT with the cubics, or the cubes, sorry, not cubic. We're going to get minus 3x squared. Then we would do our squared terms. Cubed. That makes boo-boo. Thank you. Cube. Thank you. And then our last term would be plus 15x. So this would be our final solution. What we're looking for. So it's just being able to expand the whole thing out. Something I believe you guys should definitely be able to do. So keep that in mind. Keep that in mind. You actually sit somewhere else. Actually, right here. Did you just barely show up to campus? Do you mind me asking? Right here. What'd you say? No. Look, I'm not going to get mad at you guys showing up. You guys know where you need to be. I'll mark you down late. For those that showed up later, mark down late. You know where you need to be. I'm not going to cry over it. Why cry? Okay, here we go. Let's do this. So we're going to skip that, skip this. We are going to do this. Let's start this one up. Do me a favor and copy this down. Now, what you guys did last year using division, long division of polynomials, and what you guys did with synthetic division last year is they always told you what it's being divided by. They always told you, take this polynomial and divide it by this. Take this polynomial and divide it by that. What we're going to get to is finding the zeros without knowing what to divide. And how do we determine what those numbers are, right? Because technically there's infinite amount of numbers we can use. We can find different ways of solving it out, but what do we use to solve out and find the factors that represent these numbers? So we want to be able to see these and what those represent. The rational zeros of polynomials, okay, will help us determine how we find out what we can look at to factor and solve, or what values we can use to give us zeros. And that's kind of crucial. Now, let's consider how these two things are done. We're usually taking our expanded form of our polynomial, and we always want to be able to kind of determine what these are going to give us by looking at the factors, right? We're always going to take this polynomial and be able to factor it, because our factor terms are going to tell us where the zeros are. We know the end behavior. We're going to be able to graph, so forth and so on. We're building on this idea of being able to graph and understand this function itself, just by looking at solving for the zeros, the y-intercepts, and everything. Looking at this really quick, can we just describe the end behavior? What's the end behavior always going to be? Right? Positive and odd. That means the further right it goes, it's going to go up. The further left it's going to go down. Okay. What is the y-intercept of this one? 24, right? We always consider it the constant value. Okay. And the fact that we can actually go a step further and say that we have factors of this, what are the intercepts, or what are the zeros for this function when we have it at 2, 3, and -4. Now, what would happen if I did not give you this factored form? How would I find out how to factor this out? The ways that we did it before, without using long division, right, if we don't have these values, is what would it look like we would do with this first one? And find a way to group them. We definitely find a way to group them. Not going to always be that clear. What if I give you a polynomial of 5th degree that couldn't be grouped? What if I give you one that was 7th degree? Okay, not going to be always that clear for us to factor, but we should be able to do it with a degree of higher than 4. right? And how do we determine that? Okay, we want to be able to look at the relation of the factored form and the standard form. And what we're going to look at here is, let's just take a look at these values. What is -2? So we're going to take our constant values. We're going to take -3. And we're going to take our last one, 4 here, right? Because the root of this problem is understanding where the factors come from. How do we get the factors from these, right? This is where the root of the problem comes from, right? Because these are zeros. This is what we want to get from here. So how do we get that? Now, if you were to multiply these two out, or all these three numbers out, what is -2 times -3? Times 4 is what? So in this case, when we're looking at here, we're looking at this idea that's coming from this constant value. And we want to be able to determine what those values are. And if we look at the factors, if we specifically look at the factors of our constant value and our leading coefficient, we're going to be able to determine all the possibilities to find our zeros in order to make this factorable. Okay? Some of them are going to be very simple, very quick for us to do. Some of them are going to be a lot more. And the idea behind using chapter 3 is there's multiple ways you can do to solve this. Some of you guys enjoy doing synthetic division. Sometimes we're going to use the rational roots theorem. What happens when you can't factor? What do we have to use? What happens if we get complex numbers, meaning negative ones underneath it? What's going to happen with that? So this is what we're going to kind of lead up to. And the understanding of this is going to be kind of crucial, so we're just going to focus on finding our numbers today. I will show you guys how we're going to apply them, but it just all depends on what we're going to do here. Now, here we go. Here's what I want you guys to copy down. Copy this down for me. Now, copy that. I'm going to erase this really quick because I want you guys to be a more simpler idea, because it was getting too confusing with other kids. A sub n of x to the n, meaning the highest degree with the leading coefficient of a and n. A sub n is our leading coefficient, plus whatever terms that will be added will be equal to our a naught, meaning our constant value. And we're going to be able to look at these in order to find these numbers. Okay, we're going to look at the integers of the coefficients. We're p of q, p over q, meaning our constant over our leading coefficient, meaning we're going to look at the factors of those and determine what those values are going to give us. Okay, some of them you might have only 4. Some of you might have only 2. Other cases you might have 10, 14. Which ones do you do? Which ones do you plug in first? How do we solve those out? This is kind of crucial. This is going to make up a lot of your test. Understanding how to do this is going to be very crucial. And tomorrow, this is all we're going to do. I'm not going to give you anything harder than what it is, because I want you guys to be able to do problems like this. Okay? And using synthetic division and using ideas that's going to expand. And how do we find these values out? And looking at zeros and being able to graph. So we're going to look at just a wide range of these. And it's important that we're able to do. Yes?
Is the n a subscript?
Subscript. A sub n. Yep. Subscript.
So the a and the x are capitalized, right?
Yeah, a and n are capitalized, yeah. If you can think about it, that's capitalized. The biggest idea behind here is that you understand this. This is important. Exclamation point, important. We got to be able to understand this idea. But the factors of the constant value over the constant values of the leading coefficient are going to determine what possible zeros you can have for each polynomial. And it will work with any of them. Okay, it will work with any polynomial, whether it be a degree of 1 or degree of 1,000. Bigger with 1,000 because you have a lot more terms, but it should be the same idea between all these. So you got to be able to do it. This tastes like snow cone, and it's like super sweet. Snow cone, but not Jesus. It's too much. Hey! Hello. Let's go and pick it up. This? Yeah.
Heads up. Do you have any work for him to make up? Or... Sorry, Joey.
Joey. If everything's posted online, I usually print out the stuff.
Just give him a couple days for a minute.
Otherwise, it'll be good.
Here's the plan. He's going to transfer into my third grade. Or fourth grade. I have a third grade. So he just
get out of
Good time.
Okay. So what would be a problem for him for?
It's going to be way better.
With going 3, 4, 5, 6. Hopefully, dress it. Can handle it.
He's a little question about everything. He's a smart kid. So far, so good. So far. Didn't see nothing. Quick job.
Stuff. Oh, that's so good.
Remember?
Yeah. Oh, yeah. Free Calc. Stats. Have a good day. Thank
You
you
too,
for your
man.
help.
Gotcha.
Stuff in here. You need to open up the door.
Well, they had
You have the AC not in here?
I do, but
The blower, the wind blower.
we had that.
Is it not stuffy in here?
I can't see.
It's up to you guys. That's not my fault.
You see that one thing? He's like sleeping.
But we can do some more.
Oh,
I think I know what I'm saying. Working hard over here around here. Yeah, nothing like watching.
So hard today. Now, what we're going to get here is the following. Okay, we're going to look at rational. We're going to try and find factors. And what I'm going to do is I'm going to clear this so you guys can kind of follow along with this. But let's look at this idea of finding factors. So let me clear this. Let's find this idea of finding factors for our problem here. Say what? Okay. Now, let's do a quick idea of this. Let's say I give you, I want to try to find 2, 3, and 4. 2, 3, and 4 is 2 times 3. So let's look at factors of 24. How do we find the factors of 24? What does the factors mean? Anyone? Yes. Things that go into 24. 6 and 4, so we can use a factor tree. 6 and 4. In this case, even do it just more simpler than that. What does 6 and 4 break down to? 3 and 2. What about 4? 2 and 2. Okay. You can do it that way, and you can find multiples that way. You could also do your factors of them. We'll keep it that one. We'll just keep it that one. I'll show you guys this one. And we even know we can even split this down even further and say that we can have it even 2 has a factor of 1 and 2, right? This would be 1 and 3, and then 2 and 1, right? So our factors for these, we're looking at the factors of 24, are going to be plus and minus 1, plus and minus 2, plus and minus 3. Because depending on which is positive or negative can give us a positive 24. Right? If we're both negatives or both positive 24. So we want to be able to look at these factors that can form when making these values. So when we're talking about P over Q, we're talking about the factors that we're creating between these values. And we're going to look at just an example like this to help us determine what these values are going to give us. Does that make sense? So let's continue. Now, before we move on to this one, what I'm going to do is I'm actually going to change this problem. So copy down the example. We're going to use this example up here. Finding rational zeros, the leading coefficient happens to be 1. What happens when the leading coefficient is 1? Find the rational zeros for this. And I'm going to, this is going to take us the longest example, so you need to have a little bit of room for this because I'm going to show you two ways. And if this is the only example we get through, at least we have a good understanding of how to find these. What does it mean to be zeros? What does it mean to find these? So we've got to be able to do these. And we're going to expand on to more problems, but if you can get one of them, you can get the rest of them. Looking at these, we want to be able to use our theorem, in this case, the rational zeros theorem, to determine what these values are. We know P over Q is going to be the factors, a factor or factors of the constant, over the factors of the leading coefficient. I'm just going to put leading. And this is basically what we want to be able to look at when solving these. Now, pretty much we want to be able to factor this out. If we can factor out that top one, x cubed minus 7x plus 6, it would tell us what those zeros represent. But what happens if we don't know what we're dividing into? If it doesn't tell us that it's a factor of it, how do we determine what those values are without using the conventional way we did before, whether it be factoring or another way? Now, with these, what's the constant value for our first term? What's our first value here? 6, right? Our constant value is plus 6. So what are the possible factors for this? What's possible factors of 6? 1, 2, and 3. We can show combinations of these. 1 times 6 will give us 6. Negative 1 times negative 6 will give us 6. 2 times 3 would give us 6, right? There's different ways we can look at these factors, and depending on how we want to do those is going to be important. What is our leading factor? 1. So if we're looking at 1 in the front over here, what is the factors of 1? Just 1, right? In and itself is a prime number, so it's itself and 1. So it's just 1. 1 is 1. Right? These are the combination, these different ways are the combinations we can actually look at to see which are factors. So the possible zeros for these, yes.
Is there a comma between?
Yes, yeah, these are, sorry, it's shown on mine but not on yours. Okay, these are possible factors that we're going to get here. So possible zeros that we're going to get here is plus or minus 1 over positive 1, plus or minus 1 over 1. We can get plus or minus 2 over 1, plus or minus. These are all the possible ways we can see these as factors. Okay, these are all possible zeros for these. And it's not going to be always as clear because sometimes we might have different factors and fractions when doing these. I'm going to erase this top up here. If we were to reduce these, we could actually reduce these down to be plus or minus 1, plus or minus 2, plus or minus 3. Right, just creating simplifying the fractions. So our possible zeros for these zeros is going to be 1, negative 1, 2, negative 2, 3, negative 3. These are all the possible ways we can make, or with these zeros, these are the possible ones that we can make from those. Okay, these could all be factors. We can all make factors and find these out. Not all of them will be, but we got to be able to determine that. Now, there's 2 ways of doing this. There's actually 2 ways we can do this. And depending on how you want to take it is going to be up to you. I like using synthetic division because it's easier for me to understand. I can easily do it because I know the fraction itself. I like adding and subtracting. It's just easier for me to do. The other way we can do it is what we learned yesterday. That if we plug in any of these zeros, if we get P of C, so we'll just show a couple of examples. I'm going to kind of erase these. We'll do both of them. We'll do, yes.
For answer B, like, do we have to expand and write it all out, like 1, -1, 2, -2, or can we just leave the plus or minus?
You can leave the plus or minus. You can. I just wanted you guys to see it the whole way.
I know.
Yeah. Now, for this, so I didn't spell synthetic, right? S-Y-N. God, horrible at spelling. The E. I see. Synthetic or These are the two ways you can actually do these. Remainder theorem tells me that if anything I plug into my function and gives me 0, means that it's a factor. If you were to plug these all in, we're going to be able to determine which one's a factor and which ones are not, right? Just by being able to plug in the values into the function itself, we're going to be able to determine that. And I think I need to look at what the, made a boo-boo because I need to find out what that is. All right, that's our polynomial. Sorry, I need to have that out. Okay, can't just wipe it all out. Okay. The other way we can do it is being able to use synthetic division and using each one of our terms to use synthetic division to find out if the remainder is 0. Okay. How much more time do I have in here? Do you know? 12 minutes? Okay, that's fine. I'll finish this one up. So what we're going to do first is I'm going to use synthetic division. I'm missing a term in this part, so it's going to be 1 on the outside. I'm going to test my first point here. This will be 1, 0, -3, and 2, because I'm missing that x squared term. And we can automatically determine whether this is a 0 of this function. This other way we can do it is by plugging in 1, P of 1 into my function. Whichever works with you guys. And let's do, this would be like 1 cubed minus 3 times 1 plus 2. Both represent the same exact thing. If we're doing this, we can reduce down to 1. 1 is 1, 1, 1, -2, -2, 0. Is this a factor? So 1 minus 1 is a factor. This would give me a 0. This is a factor. Both ways are doing the exact same thing, right? Both of them are doing the exact same thing. So both of them would be a factor. So that one works. Let's check our -1. Let's check our -1 here. If we do -1 for our synthetic division, 1, 0, -3, and 2, and I'm just going to show you why it wouldn't work just really quick. You can actually stop there. So what am I doing here? What am I doing? Dropping this down. 1, -1, -1, 1, -2, and 2, 4. Is this a factor? Not. So we would say x plus 1 is not 1. And if we do P of -1, we're going to get 4, which is again not a factor. Do you see what we can get between both of these? Now, there's a difference between using the factor theorem, using synthetic division, and using your remainder theorem. If you use a remainder theorem, you got to be able to plug in every single one of your possible values. If you're comfortable with doing that, go ahead and do that. This would come out, you would plug them all in, and we would get values in which would be factors or not factors. But in this case, if I just do one of them, we know how to rewrite this polynomial. And this is what I'm going to kind of show you. This is why synthetic division is kind of nice, and they show you a lot in this. Okay. What's our remainder for this? If x minus 1 is a factor, what would be this polynomial that we're getting here? It would be x squared plus x minus 2. Okay. We would be able to rewrite this as a factored term because we know synthetic division just takes it one step below. Is this factorable now? What would the factors be? What multiplies to give us -2 but adds up to give us 1? What would it be? -1. Does that make sense? Do this one, right? Oh, because I didn't even do it the right. Did I do the wrong one? I think I did the wrong part. It's okay. Okay. It's all right. We should have done it with another problem, but it's okay. Okay. The same idea applies for all these. Okay. Yes.
The stuff like you did the arrow and you did the x minus 1 and you open plus x squared plus x minus 2. Is that something that we like?
Let me do this real quick for you guys. Let me show you. Because the polynomial is a bit of a mess up. The problem that we did for this is x cubed minus 7x plus 6. So if we do if we do the possible value of 1, okay, if we do this possible value of 1, this is what we would use. One. So this would be x minus 1 is a possible value. If we were to rewrite this, this was the problem we would have looked at, guys. I'm sorry. X minus 1 in which our possible values would have been sorry, those would have been our factors. Sorry. Okay. Did a little boo-boo on that. Okay. This is why synthetic division is a little bit nicer. Okay. Now again, I just want to recap on this. We did P over Q, the factors of P over Q, to find the possible values of our factors, of possible zero values. There's two ways of doing it. If you want to plug it into the remainder theorem, I mean, if they give you zeros, that means they're going to be factors for your solution. Okay, but you got to be able to plug in all those into your function value. Okay. Now, if you were to do synthetic division, every single time you do a synthetic division, it drops the degree down one step less. So in some of these factors, you probably can do it twice and get a factor that's easy factorable. So depending on which way you guys want to look at it, this is what we're going to do tomorrow. We're going to do both of them. Okay. But what would happen? We're going to look at some case in which would happen. What happens if this is not factorable? What's the way we can solve the solution out? What's the easiest way we can do it? Quadratic equation. Okay, so there's different ways we can look at it. Okay. Yes?
No, so what do we do after the synthetic division? Like you have the x minus 1 when you determine that it's a factor?
It's a factor. In this case, we can get it here and do the same kind of idea where we're going to simplify. Okay. So you can do it every single one of them. You can do it to every single one of them. Okay. If you want to continue this idea, and in this case, because I know one of my factors is 3, if you're to do synthetic division to all of them using the same polynomial, let's say we use -3, right? Because I know this is a factor. If I do -3, 1, 0, -7, and 6, and the remainder is 0, so you could do synthetic division with every single one of these terms. And if it comes to be 0, you know that those are all factors. We drop it down the first one here, getting 1, -3, -3, 9, 2, -6, 0. Oh yeah, x plus 3 is a factor. So you can do this every single time, and this is what we're going to look at. Sometimes it's easier to do it that way. Sometimes it's definitely easier to do it that way. So you can do, that's what I mean, this is going back different ways. A lot of people like using the remainder theorem by just plugging in, they find all possible zeros. Other people like using this idea of being able to use synthetic division, use an x polynomial down, factor it, and be done. Others like using just all synthetic. Do synthetic division using the same polynomial 6-7 times, because it's easy for us to do. And you'll be able to know by the last step you do it whether you have it or not. And we're going to show, we're only going to do like 1 or 2 problems tomorrow because it's going to require us to take a long time to do it. Does that make sense?
Yeah.
So there's 3 essential different ways we can solve these out. Okay? Here we go. How much more time do we have in here?
10 minutes.
Okay. Do me a favor and let's look at all possible zeros for this function. We're not going to solve it out. We're going to do it all tomorrow. We're going to find the zeros tomorrow. But what are all the zeros can be? What can be the zeros? What are the possible zeros for this? So we want to be able to look at all possible zeros. And that's where we're going to end. We'll finish this up. You only have 4 homework problems tonight. And what you're just doing that, you're going to find all the possible zeros for me. That's all you're doing. Yes? Oh, crap. Yeah. I'm going to have you guys come up here and sign it just so I know that you guys are taking them. Okay. Sophia, Sarah, Cassandra, Brent, Omar. Thank you. Come up inside for me first, and then I can give you guys them. As I'm calling you guys up, just come and do these. Caruso, Yee, Kayla, Kyle, Dotson, Franco, Garcia. You're welcome. Nathan, Graves, Gordon. Guys, let's tell you guys to be quiet, please. Graves. Can you tap her on the shoulder and please come up? Looking at the factors of these, we're going to get plus or minus 1, plus or minus 2, plus or minus 3 over plus or minus 1 plus or minus 2. These are all of our possible ways we can look at these. Thank you. Mr. Gross, Ham, Hernandez, Howard, Cushman, Lindensmith, McGee. Over those, we're going to come up with our fractions. Oh, that's not yours. We're going to come up with our fractions, where we're going to get plus 1, plus 2, plus 3, plus 1. These are all the possible ones we can reduce. Griffin, Valerie, Vincent, Dominique, Sean. Now, because we actually have a pair that repeat, 2 over 2 is the same thing as 1, we can cross one of them out if they're duplicates. Yeah, in this case, or you could do 2 over 2. You just need to do one of them because they represent the same thing. Pickle, Crowdy, Yona. Oh, did I give you the wrong one? Sorry. Right. Zyron.
You gave me minutes.
I know.
Yeah.
Yeah, my bad. Make sure you guys sign it. We can reduce this down and just get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 1/2, and plus or minus 3 over 2 are the possible chances. Which ones, if you want to find the zeros, which one will we do first? Do the whole numbers first. Fractions are horrible. Okay, unless you really know how to do them, don't do the fractions first. Can I give you guys your homework to start out? This is all you're doing today. Here you guys go. We're going to cover more of these tomorrow. This is all we're doing tomorrow. Might seem like a lot because we haven't got there yet. Here's what I want you guys to do. 1, 2, 3, and 4. This is already posted? Yes. In this case, 2 over 2 is the same thing as 1 over 1. Cross out duplicates, right? Because if they're not the same, if they can all be reduced down all your forms that you can. If they repeat, you're good. What's up, bud? So reduce them as best you guys can in order for you guys to solve those out. What's up, dude? What's up? Struggle's real. Struggle's real. Sorry, dude. Is this easy or hard? So you guys, this will be on that one. Bye, guys.
Bye.
Will you stop and watch this?
No, I didn't get it, bro. I just, yeah.
I don't like her. I was in yesterday, and then
I've opened these, but I don't know if it's it's not because of the
that's what it is. And then like, what I don't get is she, like another thing I really didn't like is she was like, oh well, someone was like, oh, we gotta check this. And she was like, she was doing some things or whatever, like the drop off thing or whatever. And she said, no, it's time for giving. And she was just standing there doing nothing. I was like, yeah, that's gonna be fun. I'm not gonna. And I'm trying to get yeah, then I'm gonna try to get because I have this
probably here's what's gonna happen. Pretty much because you guys are
Yeah.
and the only the person that has someone for you guys is very clear which is
Do you remember which one it is?
it's good clear I don't understand.
but then I'm gonna go right now because like
It could transfer you into Campbell, it could transfer you into
Bye, Miss Rez.
no, I'm not in
You switch out?
yeah, I have her first period now.
This is
It's going.
Oh my goodness. Like going really long.
oh, you know it should. I mean,
Yeah, it's not working.
right now it's not working?
Oh, that's why I should. That's why I should. Wow.
I should watch it one episode.
Yeah, you can't watch one episode based off that.
No way.
I watched like 2 minutes of it and I got
No. Yeah, look up 2 minutes of a show and expect to start it. It's like buying a car, not even turning it on yet. Yeah, I kind of see it slow. Not even just turning it on.
Same exact shoes as me.
Do me a favor, let's go. Let's go. Homework out. Are you late? What are you doing? Let's go.
Press.
Don't do that. Come here fast.
I was right there.
You're late.
That's disrespectful. It's disrespectful. You know you're not supposed to. Right? Come on.